In continuation with yesterday's discussion of elastic block storage, we are going to see the different types of block storage that is available. We used some of them yesterday when we were doing the demo classes. So today we will continue on the same theme, and we will see what other storages are there and what are the options that we get for navigating them. I'm just making my screen fully possible, so visible. Okay, yeah. Okay, here we go. So typically, disks come in either SSD based disks, that is solid state disks, which give you very high, very good performance, that is on the left hand side. And then you also have magnetic spinning disks, which are relatively slower in terms of input-output operations per second, but at a relatively cheaper cost. So if you are having a workload which is running a relational database, then Amazon recommends you to choose one of the I01 disks, because for critical IO sensitive databases requiring that much of consistent performance, then that is the disk ideal for you. So in other words, if you have a workload and if you know what is the workload's IO operations per second requirement, then you can choose the disk accordingly. So instead of going ahead and choosing a disk which looks good on the screen, which says that I am capable of 20,000 IOPS, I like SSD disk, and I will go ahead with SSD. You rather choose based on your workload. So if you're talking about relational workloads where consistent performance is important, then you choose I01. Whereas NoSQL is not needing consistent performance. It is going to be a spiky or bursty workload. Suddenly there will be a lot of requests or keys or values coming in. One person might be storing a lot of images or uploading images, and after that somebody might be retrieving it slowly. So if you want a boot volume of an OS where you are going to read a lot of data in a very short span of time, then that case you are going to need a GP2 kind of a disk, where it allows you to read a lot of data suddenly and write a lot of data suddenly, and then the performance is predictable for that period of time. So that is when you are going to use a GP2. You don't have to memorize it. You can always go ahead and find Amazon documentation related to how the disks are named. So when you say IO, it is input output optimized. GP is a graphical performance optimized, or spiky bursty workload optimized. In other words, you can remember it like that. And that is for the SSD based disks. When you come to this side of the screen, you have the spinning magnetic disks, which is relatively slower when you compare it to the SSD disks. And then here you have two categories. One is optimized for big data, and another one is optimized for that one is, I'm not sure what it is optimized for, media. Yeah, streaming media. When you're talking about the streaming media, it is a very unique kind of workload, because let us say you're trying to watch a movie for 1 GB in size. You are going to read 30 frames per second if it is an HD definition, or if it is a very high definition, you might be reading 60 frames per second. In other words, you will be reading some 4 to 8 MB per second. So you know that what is your demand, and you know you can do something like there is a media buffering. Is that we are familiar with the word of media buffering. So what happens is the data is read prefetched, and it is stored in the RAM. And for those kind of workloads where your amount of data that you're going to read, or where the data is present exactly, is linear, then that kind of a disk, that is SC2, SC1 disk, is ideal for that, because you know you are going to watch the movie first and then you are going to watch the second scene. Very rarely we do a seek operation, that is we jump from one scene to another scene, but most of the cases you will be watching in a very linear fashion. In that case, this kind of a disks are ideal, where the cost is also lower and your input output operations is also not going to be very high. So there is a very simple diagram or a flow chart, I can rather say, on how to choose different type of disks. So as I said in the beginning, it is your input output operations and your throughput. How much of the input output operations you need, or are you going to have a small random input operations or large sequential IO? When we talk about a large sequential IO, we are talking about a new media file, that is a streaming operations or something like that. When you're talking about a small random, big data does this quite often. It requires data that is spread across a lot of disks, and the I/O is also going to be very random. That is very small amount and but distributed over a lot of places. Whereas when you're talking about input-output operations per second in the left-hand side, IOPS, it is typically a database workload, whether it's a consistent database or a NoSQL database where spiky demand is required. And then comes the latency requirement, how fast you want to retrieve the data. Then if you have something like less than 1 millisecond, you directly go to I2. And then if you have a cost in mind and the performance in mind, you want to balance those two, cost and performance, then you choose between GP2 and then I01. In other words, if you want a lower cost but very good I/O performance, then you typically go for the graphic performance. Or if your performance is more important to you and cost is not, cost is going to be secondary, sorry, then you are going to choose something like I01. When you come this side, again, aggregate output, that is how much rate of data that you are reading at any point of time. That is going to be that is a pipe that you are getting to your database, or a disk is important. If the pipe is going to be bigger, then you go straight forward to a D2 disk. If the pipe is going to be a requirement for a pipe is cost sensitive or performance sensitive, then you choose a disk that is appropriately sized to either SC1 or ST1. Your company might or your organization might have a different kind of a flow for that. Just remember that you have multiple varieties of disks for each and every workload that you can imagine, or you can have a combination of multiple disks, create your own RAID 5, RAID 6, which uses multiple disks at the bottom, and then you can use that as well. So your I/O operations is also optimized and disk level is also optimized. So this is just an example scenario on how to choose your volume type. So next is, we touched upon this yesterday. So we can increase the volume size. Say for example, you are from a GP2 disk and you are having a 1 terabyte disk. You can move from 1 terabyte to 4 terabytes or 16 terabytes. Likewise, almost all the disks in EBS, that is this concept is relatively new, elastic volumes. When Amazon launched EBS, this feature was not there. This is there from the last couple of years, I think now. So you can move dynamically change the size of the disks from 1 GB to 10 GB, or 10 GB to 100 GB, or 100 GB to a terabyte also. That is also possible. Remember, if in yesterday's demo, we saw it move from 10 GB to 15 GB and we resized it. Likewise, there is one small constraint is there. Can you decrease the size? Not as easily. If you go to the console and if you use the actions button, you will not find a decrease volume button directly, because there is a possibility that there is an impact to the underlying data. So Amazon does not easily give you an option to decrease the data. Then what you need to do is you need to take a snapshot into a smaller volume and use that snapshot for mounting another server, or you are sharing it with somebody else. So if you want to decrease your volume size, and taking the snapshot, which is in other words is a backup, and then you use the backup disk for next server. And there is another option is also possible. You can change volume types. For example, you can go from GP2 to I01, and you can likewise you can go from ST1 to SC1. So it is possible to go from one SSD disk to another SSD disk, and spinning disk to a SSD disk. So all these combinations are also possible. So your from I/O operations to your workload has changed into a throughput-based operations. Then you move your disk also in the same way, so that you get enough throughput instead of maximum I/O operations. So any combination is also possible. There are some restrictions. There are some caveats. That is, if you have this much size, you cannot go here. If you have this much I/O performance, you might not get it. So just imagine that it is possible to a certain level. It is called in technologies space, it is called edge cases, because some customers would have customized their environment to a very different level where the most common scenarios will not fit in. So most common scenarios you can move from one disk to another disk, but there are some very edge scenarios where it might not be possible. So generally, in your exam case or your interview purpose, tell them that it is possible, But if you have a very highly optimized disk using multiple RAID logs, multiple RAIDs, then it might not be possible to move from one disk type to another disk type, that is SSD to magnetic or spinning to cold storage or all those things. It might not be possible in some cases. Moving forward, so this also is possible if you have something like the base was, if you remember, it was 100 slash 300 IOPS. That is the default or standard IOPS you get. You can move that anytime up or as well as down. This is different from your disk size. So remember that you can not increase, you can increase your disk size but not decrease it. But whereas when it comes to performance of that disk, that is particularly when it comes to the IOPS of the disk, that is, I'm talking about the number of input-output operations per second. If you want to increase it, we can dynamically increase it, and the same way, if you want to decrease it, we can dynamically decrease it. So there is a slight difference. So remember that difference when you are talking about magnet SSD disks and EBS volumes. So both these options are dynamic. When I say dynamic, you can go to the console and choose the extent, modify volume, and then increase or decrease the IOPS. And it takes a few minutes or an hour, depends upon the size of your disk. If you have a 1 terabyte of disk, and optimizing the 1 terabyte disk to 10 terabyte disk for higher performance is going to take some time. So the console gives you a very good progress bar of what is happening on the background, whether it is optimized and how much is optimized, and when you will be ready to take it and start using it. So based on that, you can tell your customer that your disk is optimized and it is going to take some more time to get completely ready for usage. So to give you a rough comparison, we will see the timeline of the operations in the next few slides. This also we spoke about combine different combinations and modifications. You can move from spinning to SSD, SSD to spinning. It's all absolutely up to you how you want to define your environment. It's the same thing when you're modifying or if you're changing it. So this also is what is more important to your workload. This is the question that you need to ask your clients or any interviewer saying that how will you choose the disk. The first question you need to ask them back is what is more important for your workload, IOPS or throughput, whether it is input output operations or amount of data that you can read at any single second. Based on that, you can recommend either an SSD based disk for IOPS, or you can recommend a magnetic spinning disk for throughput or workloads. So this is a slide. If you can memorize the data in this slide, you can very clearly answer some exam questions as well as interview questions. There is definitely one or two certification questions on this topic. That is how you are going to choose your disks, whether it is IOPS or throughput. If it is IOPS, what kind of disk? If it is throughput, what kind of disks? So this is a simplified version of performance and volume types. So we spoke about this quickly. I will just run through the slides and then we will talk about how to create a snapshots today. So this is how we create the volume. I just modified the commands a little bit so we can have an error-free run of the commands. So if you are using a Linux machine, these commands will definitely work, especially in the Red Hat Linux. These commands, I've tested them and these commands will definitely work. And here you have a star here. Instead of the star, if you do an ls block, the device name will be visible. It might be A or B or C or F, whatever you give, something like this, dev/xbdf. You have to use the same thing, and the same commands will definitely work there. And you can go ahead and mount the volume and do some touch command or create a file or do whatever you want. And for modify volumes, it is better to do it in the console rather than in the command line, because we don't have to remember all of these commands for modifying a volume. And I will show you today how to modify a volume and take a snapshot later. For now, you just keep it in mind that it is possible to modify volume, either it is from increasing your IOPS or increasing your disk size. Both are possible. So this is a modify volume timeline. I talk about why you need to speak to your customers to saying that it is going to take some time. Let us say that you want to move from GP2 to I01. So the first thing you do is you use the modify volume API and you initiate the modification. So then the modified state is going to be updated in the console. So that is it will take a few seconds to update the status of the disk, saying that it will be modifying. And then what happens is it takes a while to reach the optimized state. That is both the performance between both the volumes. From that is this volume is the source and this volume is the target. So the performance has to be optimized for the parameters that you have chosen. And only after you reach a certain amount of time, that is optimization is completed, then the target volume is available for the same level of performance. So this is what is happening at the background, and you need to tell your customer saying that this is going to take a while, especially your disk size is bigger and it is going to be optimized for your target level performance. And once it is ready, then we will be able to use it. The action that you initiate on the console is instantaneous, but the background operations takes a while to take into effect. So let's move forward. This is commands for extending the volume. The same commands work. I have checked it. We are making the file system. We are making the directory, and then we are mounting it here. After mounting and after you issue the extend volume, you just go and resize the device. When I say device name, it is nothing but a /dev/xvdf or whatever the dev name, device name you are using. And this works for ext, ext3, ext4. So remember, I have used the ext4 file system. This is similar to the NTFS or a FAT32 file system we use in Windows. Or if you are a Mac familiar person, if ext also must be familiar with you. And Mac have their own operating system as well. XFS is another file system. Do whichever file system you are comfortable with, and then when you are issuing the command, choose the appropriate command that will resize it. Resize to FS might not work in XFS, it might be something different. So you will have to Google that. So anybody here with a Windows background, and if they want to know how to create a disk or format the disk or extend the disk in Windows world, this is how they will have to do that. If you run the command, disk management dot Microsoft services, that is disk management dot MSC, you will get this terminal, and this terminal will list all the raw disks. And what you wanted to say something? Okay, let me continue. So this disk management GUI will list all your raw disk, and you should be getting D colon or E colon depending upon what you have in your computer. Then you can right click on that disk and then choose extend volume as it is shown here. Or you can also, what you can do is if it is a new volume, you can format it and then create a drive and then extend that volume. So you do this, that is creating your volume or extending your volume based on which step you are doing. And then go ahead and change the size, whatever size you want. Probably after increasing the disk, you don't want to create a drive for all the space. You want to create some free space. So you choose only a smaller amount. Say for example, here it is 100 GB, but they are creating a disk size only for 70 GB. So that is also possible. It's up to you how you want to partition your disk, how many volumes and drives you want to create it. This is just a sample scenario. Go ahead and experiment with whatever you feel like doing it. And just a reminder, in you most of you must be having a free tier account. In a free tier account, 30 GB of EBS volumes is free. So if you are going to use more space every day for 30 days, you are going to be charged a little bit extra. So don't play around with 100 GB disks. If you want to extend the volume, start with a 10 GB disk, extend it to 20 GB or 30 GB, and then come back to 10 or 20. Just don't play around with 100 or 1 terabyte disk, because it is possible. And I will repeat it, it is possible to create a 16 terabyte disk from your account, but your cost and charges will be higher comparatively. For learning purposes, 30 GB is more than enough space to play around with. Let's move forward. Okay, snapshots, it's a very interesting concept, snapshots. Let us say that you have an EC2 server or any server for that matter here. So, and you have attached 3 disks here. As you can see here, these 3 disks are attached to the server, and you want to take a backup. What happens is when you initiate a snapshot command, a backup of those disks exactly as it is sent to S3. And you can see the blue volumes here that is listed here. So you have an exact bit by bit copy of the exact data that is in the snapshots. So this is a point in time data. So if you take a snapshot and add some more data to your disk and expect it to be in your snapshot, that will not be the case. So always remember that the snapshots are point in time backup of your modified volumes, and they are in your S3 account and can be accessed through your EBS APIs only. You cannot access your snapshots using S3 directly. Always remember this. Just because you have taken a snapshot, don't try to go and search for the snapshots in S3 account. It will not reflect there. It will be available only in your EBS dashboard, and under the EBS dashboard, you will have a snapshots section. Under there only you will be find it. So having said that, these snapshots will be stored in your S3 account. That is, the charges and all the storage and the input, the read or throughput, everything happens through your S3 account. So the charges will be shown under that, but you will be able to find the disks and snapshots in your EBS dashboard only. So that is another important thing. And then we will talk about this point in a more graphical way. The first snapshot is a clone. That means that let us say you have 100 GB in your disk and you take a snapshot. The snapshot will be 100 GB. So now you have taken a snapshot, you go ahead and modify some data. That is, you add another 5 GB of data. So totally now your original disk is having 105 GB, and you take a snapshot. Amazon will only take a snapshot for the increased data, that is incremental or modified data. So the only 5 GB will go into the second snapshot. By this way, Amazon ensures that your cost of taking a snapshot comes down, and the amount of traffic bandwidth that you're consuming also comes down by taking incremental snapshots. And you don't have to do anything. Amazon automatically checks for the disks and volumes and finds if there is an existing snapshot. And if it is an existing, it automatically takes an incremental snapshot for you. And this is also another interesting point. If you delete a particular snapshot, Amazon will ensure that only that data exclusive to that snapshot is removed. So if you remove the 5 GB of 5 GB snapshot, then only that data is lost. Your 100 GB snapshot will still be there. And likewise, if you go ahead and delete the 100 GB disk, automatically the 5 GB will have the 100 GB data also. So either ways, your data is protected, and you are not going to lose all your data until you delete all the snapshots. So this way you can define how many snapshots you want to have, how long you want to keep it, whether you want to automatically clean them, and all that is possible by using EBS snapshots. So what you can do with the snapshot, you can create another Amazon machine image, you can share it with your clients, or you can create a golden image for your environment and distribute it to all the regions across the world. So say for example, your operations team is in India. Typically that is what happens in most enterprises. They will create the disk and they will apply all the patches and apply the security guidelines and create a golden image, and then they will put it into a company's account where anybody can take this base image and build their VMs on top of it. So that is also possible, and this is possible using the EBS snapshots. So we will see a quick demo on how to create snapshots and how to redistribute them as well. So this is what typically happens when you have an EBS and automatically a replica will be created. Remember, EBS is a high volume disk. That means that Amazon in the background has always a replica standby for you. So if something happens to the first volume, you will be redirected to the replica. It all happens in the background. So your EBS has a very high availability, and the fault tolerance is, the annual failure rate of EBS is very, very high. Typically, you don't see disk failures in EBS, in other words, which might be common in the on-premise world, depending upon the RAID or mirroring concepts that you use. So let us see how I take a snapshot. So you trigger a snapshot, and what happens is you send the data to Amazon S3, and Amazon S3 creates an EBS snapshot. And from here, what happens is, oh, that's an error on my part. So what happens is from this snapshot, you send it to another availability zone, or you can send it to another region also for creating a machine image or sharing it with the public world. If you have created something very cool and you want to share it to the world, then you can make your image publicly available also. I'll show you that as well. And two important things you need to remember when you are taking snapshots. Very, very important things. Lot of questions come in here in the exam. Stopping the IO, QoSing the IO. What it means is when you're taking a snapshot, you want a consistent data to be backed up. So if somebody is having an open file, and if any of you have an experience with the backup or any snapshot system, if there is an open file, it is always difficult to copy. It is the same case in Windows also, in our desktops also. If there is an open file, sometimes Windows will refuse to shut down as well. It will say that notepad is open or this file is open. How do you want to proceed? Do you want to close it, save it? The same thing happens in server levels also, in EBS also. If there are open files, your snapshot is not going to be consistent. So always flush the database and lock the tables so that there is no IO happening. And if there is a file system based operations, sync the file system and freeze the file system, that is no IO is happening, and then snapshot all your volumes. In simple terms, make sure that there is no IO happening in your database or in your file systems when you are triggering the snapshots. How you want to do it, that is up to you. There are two commands that are shown here for file system and databases, but your environment might be different, but the logic is the same. You need to temporarily stop your IO, trigger a snapshot. And the most best case, but not a very easy case to deploy, is sometimes people stop the server itself. They go to the server, they just stop the server and then trigger a snapshot. If you are a very, very small account or small company, it might be possible, but very big enterprises, it might not be possible to stop your servers. So in those cases, have a lock on your database, flush all the temporary data to the disk or a table, and then take a snapshot and then reopen the queue. Likewise in file system, sync any remote file systems, freeze the file system temporarily, and then trigger a snapshot. So remember that by your heart, always snapshots need to have a temporary pause period for your IOs. And you wait for your snapshot to return success. And when it returns success, that is, I'm talking about this statement. When you create snapshot API return success statement, then your snapshot is ready to, it is safe to assume that the action has been triggered and it will get completed on the background. So wait until the success status is returned to you, because whenever you have a very big disk, say a few terabytes in size, then it takes some time to trigger a snapshot for all the disks and the background operations to initiate and complete. So wait until the API returns to a successful state. And snapshots are supposedly faster, as Amazon says that it takes about the same amount of time to snapshot a 16 TB volume as the same as 1 terabyte volume, but wait until the success status returns, because sometimes people start using it before the success status returns, and those IO operations sometimes corrupt the snapshot, which might not be useful when you're trying to restore it. So these are the two things that you want to remember when we are talking about snapshots: stopping IOs and wait for the snapshot to return to successful state. So that is about snapshots. So this is what happens when we do a snapshot. So you have an EBS volume and you trigger a snapshot. It's not happening. Let me trigger it again. Okay, that worked. And when you trigger a snapshot, Amazon goes ahead and creates a dummy copy of it, and then they move all the bits into that. So now your snapshot 1 is ready. Then let us say something is changed. So in other words, you change a few bytes of data in your disk, and then you trigger a snapshot. And what happens, Amazon does is Amazon takes only a copy of the modified data now. So you see that how only the 5 GB of data that I spoke about is snapshotted. So you have two snapshots. When combined together, you will get all the data that you are taken in your disk. Say for example, you have modified some more data now, and you take another snapshot. So what happens is only that data is getting changed. And finally, you want to delete snapshot 1. And what happens is automatically this will be moved here. And when you're restoring snapshot 2, you get all the data. Is that clear? A quick response on the chat window on how snapshots works. Okay, great. I'm going to continue now. So what you can do with snapshots, assume that you have a typical enterprise scenario like that. You have 3 availability zones. Remember the first class I talked about a region, and under a region there can be multiple availability zones. A maximum of 6 is there in Oregon, and in Mumbai only 2 availability zones. For an example scenario, let us say there are 3 availability zones, A, B and C, and there is also a simple storage service within the region. So you have an EC2 that is a server, and it is connected to a database and connected to a disk, that is EBS disk, and you have some amount of data there now. So, and let us say we are triggering a snapshot now. So the snapshot copies all the data. That is the used data, not the unused volumes. The yellow color is the used volumes. So say that you are using some more now, that some things has been changed. So when you take a snapshot, only the changed data is copied. And again you change something. So finally what happens is when you want to restore it, everything gets copied. Everything gets copied into your availability zone. Remember I told you when you take a snapshot, what you can do is, so Amazon S3 has everything, and you go ahead and restore your snapshot 2. When you restore your snapshot 2, your base volume also gets restored, and the snapshot 2 also get restored. And you can do this to outside also. Say this is one region, and now I'm sending it to another region completely, which is outside this. And when you send it to outside region, all the snapshots get sent there. That is snapshot 1, snapshot 2, and snapshot 3. Everything gets sent. It is absolutely you decide what you want to send, and you can have very fine granular control about how you want to manage your snapshots, how much you want to store it. These are all very, very important when you are talking about backup and disaster recovery. And for database people, they are very, very keen about a point in time data. When was my last backup taken? How much table or how much transactions I can restore? So trigger your full snapshot once in a week or something like that, and take incremental snapshots and delete it every week. You can have a policy like that. So every weekend you can have a full snapshot, and every day you can have an incremental snapshot. So this is how a typical backup scenario works in the enterprise. If your restoration requirements are higher, let us say you want to restore it every 15 minutes. I mean your RTO or RPO is 15 minutes or 30 minutes, then you have to take a snapshot more frequently. So when questions about RPO and RP, okay, I'm going to mute everybody for now. Okay, when questions about RPO and RTO are coming in the interview or in the certification, what you need to think about is how many snapshots I would need to achieve that RPO and RTO. And if you are not familiar, it is recovery point objective and recovery time objective. You can Google that. There is a lot of theory and text on how to achieve those things. Basically, it means that you want to take more snapshots or less snapshots in the simplest terms, and how far away you want to keep the snapshots. If you, for safety, if you keep it in some other region, for copying it and restoring it, you might going to spend more time, so you will not meet your RTO objectives, because RTO is 15 minutes, and if your copying time is going to be 30 minutes, you're not meeting it. You are going to not meet your SLAs also. That is what it means. So another example of what you can do with your snapshots, if you have an AMI and you can send your AMI to different regions, and everybody in your company or your partners can have the same AMIs, and they can use the same disks, and everybody will have a consistent disk across the world. This way you can ensure that your environment is consistent, and operational cost or management of the cost of different VMs are going to come down. So that is also possible. You can do that with the snapshots. And what else you can do? There are, say for example, somebody has copied a lot of data or customized something. Then those are, for example, here is one particular use case. If you have great. If you have a use case to use any of the data that is present here, that is genomic data, census data, or transportation data, then you can go to this URL and then you can copy that anytime and then use that. So it's absolutely possible to do any of those things. This is for people who are using or looking for data. Mr. Hanu has a question. In 24/7 operations, it is not possible to stop the users. Hanu, we are not asking the users to be stopped. We are just asking the database to be locked. That is, the input-output operations will be queued in that scenario, and your database will have a sync lock, and then it will have a write lock, and then you will take a snapshot. So not basically you're stopping your application itself. Your application will still be processing. All the order management and the queues will be in the buffers, and once the snapshot is completed, you will be able to release the queue lock and then allow the transactions to flow through. That is what, as I said, it depends upon the application that you are supporting. It depends upon the workload that is using. If it is in file system backup, then you need to ensure that your file system freeze is in place. Otherwise, you're not going to have a consistent backup. Let's move forward. Okay, this is another thing that I always talk about. Tag your snapshots. There is a simple snapshot tagging concept that is given. You have a key of usage, and let us say this is the dev, and then you have a key of usage called a backup. So you can have any amount of keys and values. So all the dev snapshots will be deleted more frequently, whereas production snapshots will be deleted more after a review, or you want to keep it more multiple snapshots like every weekend, whereas dev is deleted every midweek or something like that. So you can use the tagging, and you know that what is the snapshot is having, what is the data inside the snapshot, and you can delete it. And when cost wise also, you can see how much the developers are using, how much production environment is using, and that is also possible when you're tagging it. So typically when you do a tagging, you can create a specific chart. Remember the first day we spoke about budgets and tagging and having the cost explorer. So you can create a specific dashboard, and in that dashboard you can say, show me what is my dev metrics, what is my backup metrics, what is my production metrics, and then you can identify what is the amount of data they're using and what is the cost associated with it. And that way you can easily monitor the cost that is associated with all these operations and control it if in case it is going out of budget. So always tag, and always tag. So finally, demo time. We will quickly look at all of those options. Although we saw about creating encryption, resizing snapshots, we can go ahead and do that today as well, because it doesn't take much time. Let's go to our console and do that. I think we have enough time today to complete that as well. Let me just quickly go ahead and close this. I'm just going to go to my console, and I'm already in my dashboard. As I said yesterday, I'm going to start a server today also for experimental purpose. If you're able to go ahead and start your own, good. If you're not able to, just follow the same steps. We will talk about starting a server in detail some other classes. For now, we are going to launch only a demo server. Just use the default options and you should be good here. There should not be any problems at all. So first of all, let us go ahead and create our volumes. So for creating our volumes, on the left hand side, there is no EBS dashboard. EBS is listed under EC2. So go to EC2 dashboard. Under EC2, if you scroll down, you have something called Elastic Block Store on the left hand side. Under that you have volumes. Go ahead, click on volumes, and you can see that I already have a 30 GB volume. Let us ignore that for a moment. I want to create a new 10 GB volume. Let me go ahead and click on create, and I'm going to change the size to 10 GB, and I'm going to leave it as general purpose. Let us change it to magnetic later. And I'm going to choose my availability zone as 1A. Remember that EBS volumes are available only in the same region. So if you want to use it in a server which is in 1B region or 1B availability zone, you need to choose this option. So choose 1B for example, and then I don't want to copy an existing snapshot, leave this, and this is the option that is very important. I'm going to encrypt this volume, and I'm just going to put a tick mark here, and Amazon is going to use my master key. That is the default master key. I'm not creating my own key. I'm asking Amazon, you go ahead and manage the keys for me and encrypt my disk whenever data is written to it. So that is all there to it when you're using encryption with Amazon keys. If you're using your own keys, you will have a drop down here, and your key will come here. You just have to select it. Click on create now. It should reflect anytime. If it is not reflecting, just go ahead and hit the refresh button here, and it should start reflecting here. So you see here it is in available state. Let me see. Let me just create a tag here. I'm just going to say Valaxy EBS demo volume. So I know that what we are talking about. This is the volume that we just now created, and you can see here it is an available state. That means that I can assign it to any disk, or I can attach it to any server, in other words. And tagging, remember we just now created a tag. If I go here also I can do that. You can have any tags. Let us say this is create another tag, and then let us say I will call it environment. I will call it dev, and click on save. So that is how you create the tags, and nothing else is there. If you want to know what is your performance of your disk, what is the key that you are using, go to the description field and you have all the details about your disk. And if you want to know whether your any app operation is actually happening on your disk, you go to status check and see what is happening in your disk, whether it is IO performance or whether it is auto IO enabled. That means that whether you are scaling or not scaling your disk. Especially these are all provisioned IOPS. That means if you define how many IOPS you want, whether it is automatically scaling to meet the IO, all those information will be available here. If you go to monitoring, it will show you the metrics about read, write, write throughput, and also some amount of queue length, all those things. Let's just leave it as it is. The read and write bandwidth for now, let us leave it as it is. Let us go ahead and create a server so that we can attach this disk to the server. Just as I said, all default options. I'm going to click on launch, click on instances, then click on launch. I'm going to use Linux once again. To be on the safer side, I would recommend you to use this option that is on the left, free tier only. So that way you will have only the free tiers listed, and you are not going to incur any cost in learning this demo. So use the Red Hat Linux and use the default option which is pre-selected, that is here, that is T2 micro free tier eligible. Just go ahead and click on configure instance details and leave everything as it is. And I want it to be in 1B availability zone because my disk is in 1B. So I'm going to choose my server also to be in 1B and go ahead and click on add storage. So this is the default storage Amazon adds, not the one that we created. So leave it, because you see that it is not encrypted and blah blah blah. It has the operating system and everything. Let us leave it as it is. Go ahead and add tags. Once again, we're going to add a tag which is going to say Valaxy EBS demo server 01. I'm going to just copy it in case I need it again. Configure security group. I'm going to use an existing security group. Okay, let us do it by default as you guys said. Okay, I'm sorry. Leave it as create a new security group. Amazon will launch you will see something like this text, and your SSH port will be by default open here. We will need it to log into the server and run some commands. So leave it as it is, review and launch. And then it gives all the data that we selected just now here. We just don't have to do anything. Go ahead and click on launch. And I'm going to choose create a new keeper. If it is a new account, you have not done this before, you will have to click on this option and give a name for it. Demo key, download the key. Okay, I'm going to say yesterday I did this, so there is a key already, so I'm going to download it again. Okay, I just downloaded here. Good. Let us launch instance. and I'm going to use my terminal, and Mobile XTerm is my favorite terminal. I would recommend you guys to go ahead and use it. Just going to show you again. I'm not going to download it today. Yesterday I did it. It froze up my computer for a minute. This is the terminal I use. Go ahead and click on download, and you'll have a home edition, free edition. Go ahead and hit on this one as well. Then you'll have a portable and installer option. It is refreshing. Yeah, this is what I'm talking about. A portable option. Use this one. There is no installation required. It is absolutely a carry anywhere. Your configurations also comes with you. The benefit is you can have multiple tabs. It automatically recognizes some colors and blah 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 nonsense. So it's very good. Better than putty if you're used to putty. So let us go ahead and connect to our server. I want the IP address to connect to my server. So I'm just going to my dashboard again. And in my dashboard, this is the server that we just now created. Valaxy EBS demo server 01. This is the one, and this is the IP address of my server. I'm just going to connect to my server and use the terminal we just now downloaded. Click on session, click on SSH, put your IP address here. By default for Red Hat Linux, the username is ec2-user, and under advanced settings you need to use the private key we just now downloaded from the console. So I'm just going to go to my downloads. Where will be my downloads? Here I'm going to type Valaxy demo key 01. So it is added. Click on OK. Automatically I should get connected. Not working? Okay, great. Let me jump to root, because a lot of operations that we are going to do is going to be in root today. So let me just increase the font size a little bit. Okay, by default I'm going to show you that how many disks we have. LSBLK will give you the list of disks. As of now you can see here XVDA is the only disk that is available in my server. So we have only one 10 GB disk. That is also shown here. When you do a df-h command, you will see that there is only one disk of 10 GB of size that is mounted on the root volume. So I'm going back to my console and attach my storage to this disk now. For doing that, go back to the console, go back to volumes, and you can see here, since I launched one more server, you can see here automatically my server volume also shows up here. So whenever you start a server, it uses a root disk, that is the operating system disk, that will also show up in your console here. So you remember the tag name that I created, Valaxy EBS server 01, automatically that gets picked up and shown here. So this is why tagging is very, very important. It makes it very easy for me to identify what each disks are and what it is containing. So this is the volume that we created, that is also 10 GB, and one is encrypted and one is not encrypted. If I can show it on the right hand side, you can see here one is encrypted and the other 10 GB disk is not encrypted at all. So let's just go ahead. For attaching, what you need to do is click on the volume that you want to attach, select it, in other words, go to action at the top, action, and then click on the attach volume option. And when you will get a new GUI window which will ask you to where you want to attach it. So if I click my box button here, automatically it will pick the running instances in my account, or if I know the name, if you have thousands of instances, it will be good if you know the instance ID or the tag of the server name. Since I have only one, it is easy for me. Amazon easily picks up and gives it. Just go ahead and click on it, and it is asking me what name I want to give. Leave it as default. Let us not get confused here. Click on attach. So you can see here the status has changed from available to in use. That means it is already being assigned to that server, and I cannot do any other operations here from the console. And let us keep a monitoring window a little bit higher so we can see what is happening here. See here, as of now my read or write bandwidth, everything is empty. I'm going to go to my server and see whether my storage is available there. So first thing we have to do is do an ls block, that is list all the block devices, and here you see XVT, if there is a new disk that is available for us. So the next step is make a file system on top of it, mkfs, that is make file system, and I'm going to say type ext4, that is my file system type, and then the device name /dev xvdf, and it has finished creating it. It just gives me a lot of blah 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 text that is doing the background operations, and it has created a disk, and we need to mount this disk now. For mounting, we need a directory to mount it. So I'm going to create something like this, mkdir, that is make directory, create subdirectories, everything, Valaxy EBS demo, and I'm going to mount my /dev xvdf, that is my device name, on this destination. So if I do a df-h now, I will be able to see another disk available. You can see here, this was the original disk we saw before, and this is the new disk that has been created in the location that we saw, /var/Valaxy demo. So I can go here, cd here, and then I can touch a file. Let us do it this way today. I'm just writing or creating a file here. It is easier to do it this way. And if I do ls-l, we should be having the demo text file. And if I more it or open it, or if you want to see the contents, it will be there. The reason I was doing is I'm trying to generate some input-output operations so that it will reflect in our console there when you go back there. So this is all there. It is to create a volume and mounting a volume. Let us go to our console and see if anything has happened. No, nothing. It will take some time probably to reflect here in the bandwidth. But if I choose my server disk, see here I'm just going back to my server disk and going to monitoring and read bandwidth. It will start reflecting. You will see it sometime. There will be a bar graph growing, but we will come back and see it. It takes some time for all the data to be collected by Amazon using CloudWatch metrics, and then it will start showing after some time. Let me change it to anything lesser here. No, last 1 hour is the only option that we see here. Okay, so let us go ahead and see what is next in our demo. We just now spoke about creating a volume. We just now spoke about encrypting the volume, and we will see now how to resize our volume now next. Okay, come on. We are going to see how to resize it from here. So select my volume here. It's not refreshing. Okay, select my volume, go to actions and click on modify volume. You can see here, come on. Okay, there is some problem with my mouse. Okay, modify volume. Oh, great. Okay, this is what I wanted to do. I just wanted to move it up a little bit. So I'm going to change it to, let us say, 15 GB. And let us say I want to use a cold storage now. I am in general purpose. I'm going to choose my cold STD. And oh, it says minimum 500 GB. Let us see if anything allows me to have a smaller size. No, none of them allows me to have a smaller size. Okay, provisioned IOPS allows me to have a smaller size of 15 GB, so that should be possible. Click on modify, and Amazon gives me a nice warning that if you modify it in the console, you need to it may take some time for performance changes to take into effect, and you may also need to extend it in your OS level also. So what we have done is two things. One is modifying the performance of the disk, and next is modifying the size of the disk also. So go ahead, click on S and say the request modification is succeeded. Remember the API call I talked about. This is what the request has been succeeded. And if I go to my console and click on refresh here, before I click on refresh, you see here it is GP2 here. This is the field I'm talking about. It is volume type is GP2. I'm going to hit refresh now. Okay, there you go. You can see here the volume type has been changed to I01 and it has been at 15 GB. And the IOPS, I did not change it. It is at 100 only, although my volume type was changed. That is also possible to increase this IOPS. And you can see here it is optimizing. Now it is at 31 percentage. As I said, it takes a bit of time to optimize the entire disk for the current performance. So while it does that, let us go back to our server and see how we can take use of the additional 5 GB that we have available now. So again, go to ls block and see our disk size has changed. You can see here the disk size is changed to 15 GB. That is, it is available for 15 GB. But if I do a df-h for this mount point particularly, it will still show as only 10 GB here. So we have a 15 GB disk, but we are still using only 10 GB. So I'm just going to resize it, resize to fs/dev. Okay, let me delete this. I think this is the command. Let us do this. Okay, it is saying that it is doing an online resizing and it has completed resizing it. It takes a bit of time and then it just comes back and saying it has been completed now, and I'm going to do a df-h like we did just some time back and see whether our size has increased. See here now the size is 15 GB now, whereas before the command resize was issued it was 9.8 GB and we were able to take advantage of a resizing also. So in other words, we have created, we have mounted it, and we have encrypted it, and we have also increased the volume. We have also increased the performance. So all with a few clicks. Probably this demo together, if I not remember correctly, took about 18 minutes for me to complete. Probably if you're not speaking to somebody and doing it, you might be able to do it faster as well. So let me just go ahead and quickly create a snapshot. Again, we are going to go back to our console and optimizing is, let me refresh it. Let us see, optimizing is completed. It should not be a problem in any case. It takes a while to complete the optimization, and that should not concern us when we are taking a snapshot. And apparently my disk metrics are still not showing because it is waiting for 1 hour. Yeah, great, we have it. Let it refresh. I've just refreshed the screen, used this tiny little wheel thingy, and you can see here my read metrics are slightly showing and write metrics are something happening because we did some small read write operations, so it reflects it. And then Amazon is also optimizing the disk, so they are copying from one disk and writing it from GP2, they're writing it into I01. So all those actions are happening, and you can see the different graphs that is happening here. So if in case if you're somebody saying that your disk is not performing and what is the throughput of your disk, then you come to this panel that is monitoring and come here and check it out. So let's go ahead and see how to create a snapshot. All I have, this is a 15 GB disk and I'm going to create a snapshot now. Click on actions and you have this option of creating snapshots. Okay, before doing this, remember that there is one file in my snapshot which says demo.txt. So let me just create some other data also in our server, so it will be interesting to watch it. It makes a nice demo to do that. I'm just going to install a web server now quickly. It shouldn't take another 5 minutes of your time, not more than that. So it is completed. Oh, I'm sorry. In other words, I've just installed a web server and just created one more file in my server. I'm just going to create a snapshot now. This might not be visible, but our demo.txt should be visible. Let me go ahead and I did not create an image from the server, but I'm going to create a snapshot. Where is my console? This is my console. Okay, select the disk. Oh, okay. Guys, you have two options. Everybody listening to me, you want me to take a snapshot of the volume that we created, or take a snapshot of the root volume? I'm asking a question to you guys. Or you don't want me to show snapshots at all today? Snapshot we created, okay. Then that is one vote. Latest, okay, fine then. Let us do it with what we created only. So this is the demo volume, and I'm going to click on attach, actions, and then click on create snapshot. It's nothing much to it. I'm just going to say snapshot from demo volume. And since it is automatically encrypted, I don't even have a choice of unencrypting it when I'm taking a snapshot. By default, it is enabled. Go ahead and click on create. That is all there to it for creating a snapshots. And remember, snapshots won't show in your volumes panel. Snapshots will be available in the left hand side. You have a snapshots column. Click on that. And you can see here the snapshot from demo volume is getting created, and you can see the status as pending. It is going to take some time for the progress to get completed, and then it is available for us to attach it. So this is how you take a snapshot. And if I go to my tagging, automatically my tags, that one that I used when we were creating, comes into the picture. And this is where the interesting things happen. When you go to permissions, you can make this snapshot public, or you can make this snapshot available to any other account number. And remember, this snapshot is encrypted using your master key, and its permission cannot be changed. Meaning, I used my own key, that is and key attached with my account. So the only way that I can share it is unencrypted, or in other words, copy the data from this disk to another disk and share it in unencrypted format. Otherwise, I will have to share the keys also, and Amazon doesn't want me to do that. So they wouldn't want share my custom master key, and they don't allow me to change the permissions here, and as long as it is encrypted. And you can see here, meanwhile, the status has been completed here. So once the status is completed, what I can do is I can create an image out of this disk, but this is not a root volume, so there is no point in creating an image out of this disk. We can only mount it or attach it to another server right now. So how we do that is go ahead again and click on volumes, and I'm going to create a volume. And if I remember my snapshot ID or snapshot, what we gave is this. Let us see, I can search it, my own snapshots. Okay, you see here, I am creating a volume based on my own snapshot now. If I click on this, automatically my key is automatically picked up. I will be able to use it, and I'm going to click on, go ahead and create. This is going to be again 15 GB disk. Let me go ahead and refresh. I did not create a tag, I guess, this time. Okay, this is available. I'm going to create, this is volume from snapshot. And you can see here it is available, and I'm going to attach this also to the same server now. Attach volume. Oh great, guys, somebody should have told me that I have created it in the other region. Let me delete this. Somebody should have told me that I have created in another region. Now that is not good at all. B, remember, this has to be B. Go ahead and click on create. Okay, it is available, ready for use. Let us go ahead and attach it to our server now. Our server is in B, so it should be visible anytime now. Yeah, there we go. And go ahead and click on attach. Oh great, I have used a 100 GB disk. Awesome. So if I go to my server now and do ls block, and you can see here I have a 100 GB disk available here. So all we have to do is make a file system mkfs-t ext4 /dev/xvdg, and voila, it has got created. I'm going to do mount point. I need a mount point mkdir/var. I'm going to use Valaxy EBS demo snapshot volume. Okay, let us use that directory and let us mount our new 100 GB disk. What is our 100 GB disk name? I forgot it. This is my disk name, and I'm going to mount it in this destination. So it is mounted. If I do a df-h, now I should be able to see all my disks now. This is my root disk, if you notice, and this is the 15 GB disk that we created, that is mounted under Valaxy EBS demo, and this is the 100 GB disk we just now created and here. So let us go inside this disk and see if there is any data inside it. Oh, did I format it again? At least somebody should have told me that I should have not formatted it. I'm sorry guys, I formatted the disk again and I lost the data inside it. If you have mounted the disk without formatting, we could have got the data. My error. I would recommend you not to format it second time also. This is like copying a movie and giving it to your friend and he formats it, the data. My error. But anyway, this is how you take a snapshot and store it. Probably I can show it later. Today it is already delayed. We are already 12 minutes past time. So I mean, at least everybody follows what is happening here. Are we good here so far?